All right, question 14 here in section 5 of the first of the GRE practice tests. We're given this compound equality that 2x is the same as 3y is the same as 4z is the same as 20. And we're told to evaluate 12 x, y, z. So let's see, a couple different ways you can solve this problem. I think the way that's most obvious, or at least that first came to mind for me, is to break this compound equality up into several different equalities. So if all four of these things are the same, then 2x is certainly the same as 20. Similarly, 3y is the same as 20. 4z is the same as 20. The reason I broke this up in this fashion is because now I can solve for each of these three different variables. And once I know what these three different variables are equal to, plug them in here and I'm done. Right, so for this one, divide both sides by 2, and we get x is equal to 10. For this one, divide both sides by 3, and we get y is 20/3. You could convert that into a decimal if you really felt like it, but I kind of like leaving it as a fraction and letting things cancel out later. Over here, dividing by 4, I get that z is equal to 5. And now I have all the info that I need to evaluate 12 times x times y times z. That's equal to 12 times, and then instead of writing x, I can write 10. Instead of writing y, I can write 20/3. And instead of writing z, I can write 5. Multiply these numbers together and you're done. I guess you could just throw them into a calculator, but it's almost as fast not to if you recognize that this 3 and part of this 12 will cancel. So that'll turn into a 4. So you got 4 times 10 times 20 times 5. And 5 times 4 is 20. So you got 10 times 20 times 20. 20 times 20 is 400. And 400 times 10 is 4,000. So it looks like C is the right answer to this question. Not super hard if you solve it this way, but maybe not that interesting. There is a more interesting way to solve it. Generally speaking, when they give you some expression, in this case 12xyz, to evaluate, there's probably a reason they chose 12 times x times y times z, right? Not just x, or x times y, or x plus y plus z or something. The 12 right here kind of stands out. That was probably put there for a reason. Well, it was put there for a reason because you can think about 12 as just 3 times 4, right? So this expression is really just 3 times 4 times x times y times z. Why do I write it this way? Because multiplication is commutative. When you're multiplying things, you can multiply them in whatever order you want, right? I did that down here when I took this 4 times this 5 and did that multiplication. You don't have to multiply left to right. So I could rewrite this as, I don't know, x times 3y times 4z if I felt like it. And you're like, why would you feel like it? Well, 3y and 4z are both quantities that I have written up here. 3y is equal to 20, 4z is equal to 20. So instead of writing 3y and 4z, I could say this is x times 20 times 20. In other words, 400x. I could turn this into a number if I just knew what x was equal to. Well, sure enough, I do know what x is equal to thanks to my work over here. 400 times 10 gives me that same answer of 4,000. I don't know that this is necessarily any easier than what we did over here. Maybe it's slightly faster, but it relies on you thinking to do it this way under the pressure of a test. Maybe for this specific use case, this more straightforward way is the better way to go. I don't know. Before ending this video, I just want to point out that in this stage right here, when I had x times 3y times 4z, instead of putting in 20 for 3y and 20 for 4z using this compound equality, I could have plugged in 2x for 3y and 2x for 4z. If I had done it that way, I would have had x times 2x times 2x, in other words, 4x cubed. And now I've again managed to change this expression, which has 3 variables, into an expression with just 1 variable. If I could solve for that variable, I'd be done. I can solve for that variable, right? Remember this little circle up here? X is equal to 10. So I got 4 times 10 cubed. Nice thing about 10 cubed is it's really easy to do in your head. It's just a 1 with 3 zeros after it. So this is 4 times 1,000, aka 4,000. Not really anything else jumping out to me about this problem, about how else to do it. So I guess really the key things are just to understand that if you're given a compound equality, like you see here, an expression that has multiple equal signs, you can take any of those things and set them equal to any of the other things to create a system of equalities. The other little hint is that when you're doing standardized testing and they ask you to evaluate an expression like 12 times x times y, take a look at that expression. They're probably choosing the things there for a reason. See if you can make your life a little bit easier and save yourself some time. I guess that's all I got on this one.